Alright, so the intent for this quick video is to showcase the performance and scalability difference between the two architecture styles that Spring provides. One is the Spring MVC variation, using which I've developed this item MVC service, and then the other option is to use the Spring Reactive technology stack, and with that I've developed the item reactive microservice. So both these microservices are similar in the functional nature. Both of them provide a couple of endpoints, but it's just that the technology is different. Just to do a quick code walkthrough, you have this items controller within the MVC app, and basically a post endpoint to create the items, and get endpoint to basically get an item list by category, and it returns a list of items. Right? So standard stuff, the database is the Couchbase database that we are using here, and basically the item repository returns a list of items, and I will basically be testing against the get API in JMeter to do the performance comparison. And again, in the reactive style, if you see the controller, the difference is basically that it is returning a flux of item rather than a list of item, because the reactive stack, it's a streaming API, and the reactive stack returns a reactive stream, and since we have more than one item, we are returning a flux here. Reactive streams is a specification that is available in Java 9, and Reactor Core is one such implementation for the reactive streams. Again, if you look at the repository service, it is returning the flux of item. So in the JMeter test, basically I will generate a load on the get API to retrieve the items by category. Okay, let me go ahead and close the ID so that performance is a little better on the system. Okay, and now this window, so this is the EC2. The configuration for both the microservices is basically one CPU and 1 GB RAM. So this is actually a T2 micro instance, and this is the one where we have the MVC service. So let me go ahead and start the MVC service, and this is where we have the reactive service on other machine, and let me go ahead and start the reactive service as well. Okay, so while these are coming up, let me also go ahead and add a JMX connection so that I can monitor the RAM and CPU usage. The J Visual VM is running on my laptop, and it is connecting to the remote instance on AWS. So this will help us understand basically when we run the load test using JMeter, it will help us understand how the CPU and memory behaves for this different stacks. So the connection has been made. I am just trying to open the GUI as well, so that we can monitor the CPU and RAM. Now if you see, this is the JMeter window from which we will run the test, and this will basically hit the MVC app, and this is another JMeter window. Again, the JMeter is again on cloud, and from this we will hit the reactive app. Okay, so one key thing to look at is basically in the reactive app, this is the event loop thread, reactive HTTP and IO1, and since I only have one CPU available on this EC2, I only have one event loop running here. Okay, now let's go ahead and start the load. So I have initiated both the scripts. So now we would be able to see some activity here. So if you see, as soon as I start the test, the number of threads have shot up on the MVC instance. It has gone to 238 odd threads. This is because in the MVC model, the server creates one thread per HTTP request, whereas in the reactive stack, it basically, the event loop is always running and is catering to all the HTTP requests. As you can see, CPU utilization is pretty good in the reactive stack, and that actually helps. A lot of time people misunderstood this, that the CPU is getting utilized, the CPU percentage is more here, so it means that this is not a high performing app, but it is the other way around, because as you can see with the numbers here, we are getting, with the reactive, we are getting a throughput of 41 transactions per second, and here we are getting a throughput of 32 per second, and this has processed around about 1929 requests so far, where this has already processed 2800 requests so far, and the throughput is also increased to 46. So this is happening because reactive is able to perform better, because there is no context switching that is happening in the reactive. The event loop is always there to leverage the CPU, whereas here in the MVC one, as more threads are coming, they are actually invoking the get API and getting blocked at the DB level, and at that time the context switch is happening and the CPU is being given to some different thread. So that is where, because of reassigning of the CPU across threads, the CPU utilization is not that great. And the same is evident in terms of memory as well. If you see in MVC, the memory has shot up almost to 700 MB, 770 MB, whereas in reactive it is pretty stable. It has hardly crossed the 250 MB mark. In fact, the reactive is already done. It has completed all the 5000 requests in 1 minute and 47 seconds with a throughput of 47 transactions per second, whereas the MVC has only completed 3400 odd requests so far. So here you can see the difference, right? MVC just finished actually, so it took 2 minutes 24 seconds, whereas the reactive took 1 minute 47 seconds. And this delta keeps on increasing as you keep adding more and more load into the system. That is where it has always been said that the reactive and non-blocking applications outperform when it comes to scalability. And with Spring being mainstream technology, now this event loop style architecture is readily available, even though with Vertex, etc., it was always there. Similarly RX Java as well, but with Spring this has become more mainstream. I think that's all I wanted to demo in this short video. Thank you for your time.